Hi folks, so the questions we're going to be going over today, guys, is about the topic of triangles and specifically constructing triangles once again, okay? It is another method for basically constructing a different type of triangle. And in today's ones, guys, they're actually on page 52 and 53 on the World of Graphics textbook, okay? So if you're looking for the examples, you can see them there. So the questions actually come from that page. Now, often you're actually going to be given a question where it says, construct a triangle ABC, I don't know, CDE, whatever it is, ABC in this case. Construct a triangle ABC that has a perimeter length of a certain measurement, okay, and the sides are divided up in the ratio, in a certain ratio as well, okay. Obviously, being a triangle, it'll only be 3 sides, okay. So for this first question, we can see here that our perimeter length is 160 millimeters. And our sides ratios are in the ratio of 2:3:4. So basically all the lengths of our 3 sides of our triangles will add up all together to 160 millimeters. And then they will be divided each side. One side will be 2 parts of 160. Another side will be 3 parts of 160, and the last side then will be 4 parts of 160. Okay, you could do maths, okay, but what we're going to do is we're going to use division of lines to help us out. So starting off one of these questions, what you'll always do is you'll construct a construction line that is exactly 160 millimeters long. Okay, so I'm going to start off, I'm going to keep it up high enough here, so about there, and I'm using my T-square now, so bear with me. I'll actually go to the 11 and 27. There we go. So that line there at this moment in time, guys, and there we go. Yeah, just make sure it's accurate. That line there is 160 millimeters long, okay, from there over to here. And what I'm going to do now is underneath that line I am going to do another line, okay, and along that line keep it about there. And what I'm going to do is that line could have been done at any angle. Now what I'm going to do is with that line I'm going to divide that up into 9 equal portions of 10. And what you're probably wondering is, where am I getting 9 from? Well, I know my sides ratios, okay, are 2:3:4. If I was to add those, 2 plus 3 is 5 and 5 plus 4 is 9. 2 plus 3 plus 4 equals 9. So what I'm going to do now is, with that line that I did off at any angle, I'm going to mark off 9 equal measurements of 10. You could do 9 15s, 9 20s, okay, but based on the space that I have left on my sheet in this little section up here, I'm going to do 9 10s. So 10, 20, 30, 40, 50, 60, 70, 80 and 90. Okay, so at that last little mark that I've made there on the line, I am now going to connect that up to the end of my line here. Okay, and what I would do is I would actually mark them off. So I know that I need a ratio of 2:3:4. So the first portion I need is 2 marks, okay? So 1, 2, okay? 1, 2. So there's my number 2. Okay? Then the next one I need is 3 parts. So 1 part, 2 parts, 3 parts, okay? And that technically is on 2 plus 3 is on the 5th one. And the last portion I need is 4 parts. So from the 5th one, 1 portion, 2 portions, 3 portions, 4 portions, okay? So therefore, you can see if I was to add them up, 2 is there, 2 plus 3 is 5, and then 5 plus 4 is 9. So at those lines, or sorry, at those points, what I'm actually going to do is I'm going to go parallel to the line that I connected up at the end, and I'm going to go parallel from number 5 and from number 2. And what I usually do at this point now is, we can see that the line has actually been divided up now into 2 parts, 3 parts, 4 parts, okay? What you usually do at this point is, we are going to now draw in the middle part, we are going to heavy in our line. Like that there, okay? Nice and simple. And then, what we're going to do is, at either end of the line, because this portion of the line that was 160 millimeters long, I am now going to put my compass at the end of that point, and that distance there that I've got on my compass is 2 parts or 2 portions of the line, so I'm going to rotate that around. Okay, and then at this part, this portion of the line, this is 4 parts of 160, okay, So I'm going to go to this portion of the line and rotate this around. And what you'll actually see is where the two arcs cross each other, I can now draw in my triangle. Just heavy that in there. So there we have it. That is the first question completed there. That portion of the line was 3 parts, so I'll put in a little 3 there. This portion of the line was 2 parts, and then this portion of the line was 4 parts. Okay, 2 is to 3 is to 4. You don't always have to use the middle, but it just makes the most sense because in the middle we can actually construct the triangle by simply rotating around the opposite parts of the lines. Okay, so using that same principle, we're now going to do the exact same thing over here for this one that has a perimeter length of 180, and we have to divide it up in the ratio of 3 is to 4 is to 5. Okay, so same principle. So what we want to do is we're going to construct a line that is 180 millimeters long. So I'll do it same height, 3, 1. So 180 millimeters long. So from the 30 to 48, so there we go. That's 180 millimeters long right there. Just to make sure of it. Yep, happy with that. And once again, we're going to do a line underneath at any angle. It doesn't matter, okay? So I'm going to actually start at this time over here. And that line has to go into 3 plus 4 is 7, 7 plus 5 is 12. Okay, so just do it in such a way that I can make sure I can get 12 equal portions. So that line went down there at any angle, and now what I'm going to do is I'm going to do 12 portions of 10. So from that would add up to 120. So mark off those. So 1, 2, 3 portions, 4, 5, 6, 7, 8, 9, 10, 11, and obviously 12 at the last one. Okay, now we know we need it divided up in the ratio of 3 is to 4 is to 5. So I'll mark out the first 3 portions. 1 portion, 2 portions, 3 portions. Okay, now I need the next 4 more portions. So 1 portion, 2 portions, 3 portions, 4 portions. Okay, so that's at the next one, and 3 plus 4 was 7. So okay, so you can see where I'm getting that 3 plus the 4 is the 7. So I just know which ones I have to mark it off with. And then the very last one should be 5 portions. So from here, 1, 2, 3, 4, 5. Okay, and that adds up to our 12. Okay, at the last point in the line, like we did last time, connect it up to the end of the line. Okay, we're just going the opposite way this time. A little bit of sliding set squares. So get your other set square underneath it. And then we're going to go to the 7. And then we're going to go to the 3. And there you have it. Okay, so now at this point, our line, which is up here at the very start, this portion of the line is 3 parts, this portion of the line is 4 parts, and then this portion of the line is 5 parts. So once again, I'm going to rotate around. I'll start with this portion, and I'm going to use the middle portion of the line as my baseline of the triangle that I want. Take the 5 parts, rotate that around, and somewhere in there is going to be the top of my triangle. And then from this part of the line, I'm going to rotate this around, and we can see where the two arcs crossed each other. I am now going to connect that up and draw in my triangle. And once again, I'll just heavy that in. So that's the side that was 3 parts. This is the side that was 5 parts, and then finally this one was 4 parts. So as we can see there, 3 is to 4 is to 5. Okay, the line there, that portion of the line is the same length as this portion on up here. Okay, so that's the second question done there, guys, on those questions on page 53. Now the next one, I'm just going to move this up here, guys, so I can see it at the bottom of the page. Okay, the next one now, just to show you this one, we have a perimeter length of 210 millimeters, and I have sides in the ratio of 2 is to 4 is to 4. So if I add them up, that adds up to 10 there. 2 plus 4 is 6, plus 4 is 10, and my perimeter length is 210. Now the way I have my sheet divided up, this is an A3 sheet. I only have roughly, I think it's 200 millimeters in between my border there. So I'm not going to do a straight line. This time I'm actually going to do a slightly askewed line, okay, or an inclined line. So just move that out of the way there. And this time I'll do an inclined line. And I'll just make sure that it has 210 millimeters on it. Okay, so this is where I'm going to do my triangle. Doesn't matter, okay, even though it's on an angle. And I'm going to measure 210 millimeters on that. Providing I can fit it in. Should just be able to, hopefully. Got that about bang on. Going from end to end. So 210 goes from there to there. It just fits on my page, okay? So it's going literally from here to here in the space that I did. Now, on that line, okay, like we had done up here, I'm going to do a line off it at a random angle. Okay, it doesn't matter. In this case, I'll come off it fairly horizontal. And what I'm going to do is 2 plus 4 plus 4 adds up to 10. I'm going to do 10 equal measurements of 15 this time. Okay, so this time I'll do 10 measurements of 15. So 10 by 15 would add up to 150. So 15, another 15. Okay, so I'm measuring out in 15s this time. It doesn't matter, I could do 10 10s, but I'm just doing 15s this time. Just know where you have to finish. There we go. These are all 15 millimeter gaps, and I've done 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. At the last one, connect it up to the end of the line. Okay. And now you can do your numbers. Okay. So 2 parts. Counting from here. 1, 2. So there's our first portion. Okay. The next portion was 4 parts, which is going to 2 plus 4 is 6. So 4 parts, 1, 2, 3, 4. So I was at the 6th, and then we should have 4 left over. 1, 2, 3, 4. Okay, and that was obviously at the 10th. So at this point now, with our line, we're going to do just a little bit of sliding set squares. Okay, this is division of lines, technically, that we're doing. So I'm going to go to the 6th one, and I'm going to go to the 2nd one. And the one I'm going to use as my baseline is the middle portion. Okay, so I'll heavy that in just to have it done. So there we go, middle portion. Okay, and I want to find a point up here, somewhere up here, for the top of my triangle. So at this point now, I am going to take the portion of 4 parts of the line. This is already 4, but I'm going to take the other portion, which is this part. I'm going to take that distance there and rotate it around, and somewhere up along that arc there is going to be the top of my triangle. I'd imagine it's in here somewhere. And the portion of the line that was 2 parts, which is this bit, I'm now going to take that on my compass and rotate that around, and as we see, we can see where they connect up. At that point there, I can now draw in my triangle. So here we go, and here we go. And once again, just want to heavy that in. There we have it. There. So 4 parts, 4 parts, 2 parts. 2 is the 4 is the 4. That is the third one done there on that page, guys. Obviously, you can see here, it did not matter that I even had the line, okay, at an angle, okay. Obviously, it makes it a little bit easier when the lines are just going horizontal, but you can do it at an angle as long as you can fit it in, okay. Just for the space that I had in the sheet, that's why I fit it in that way. Now, the last question, guys, is a little bit trickier, but they've given you a little hint on the sheet. So, it says here, construct a triangle in the ratio of 3 is to 6 is to 4, okay. And the longest side is 130 millimeters long. So if you see in this one, they haven't given us the overall perimeter length, but they've given us the longest side of 130 millimeters, and they've also given us a clue. It says, note the longest side is the baseline. Okay, so like we've done here previously, okay, kind of where the one in the middle was always kind of our baseline, that means that the 6 parts portion of our line, okay, is the baseline, and that's 130 millimeters long. Okay, so what we're going to do is we are first of all going to construct our base line. Okay, so with the baseline, I'm going to construct that. It's 130 millimeters, and I'll do it about here. I think be nice enough. 33, 46, maybe here. 130. There we go. So that portion of the line there is 130 millimeters long. I'll actually just heavy it in now while I have the chance. There we go. That portion of the line is 130 millimeters long. And now I know that is also, very important here, that is also 6 parts of my line. Okay, so 6 parts of the line is equal to 130 millimeters. So what I can actually do is, off that line, I'll do it from this side this time again. I'm going to do a random line off it, and I'm actually going to do 6 parts this time. Okay, because I want to basically get the ratio. So 6 parts, so 6 tens are 60. So you can see here I'm marking them out. 10, 10, 10, 10, 10. So 1 part, 2 parts, 3 parts, 4, 5, 6. At the last part of the line, I'm going to connect it up to the end of the line here. Okay? And then what I really need now is 3 parts and 4 parts. So if you count it out, 1, 2, 3. Okay? So that's my 3 part one. And then I could also get the 4 parts one. So 1, 2, 3, 4. Okay, so I'm going to use that to help me construct this triangle. At the 4th part and the 3 part of the line, I'm going to draw a line up and draw a line up like that. Okay, now I've actually kind of found the lengths that I need for my other 2 sides. For the 3 part side, it's the distance from here to here. So I'm going to take that distance on my compass and swing an arc somewhere up there like that. Okay? For the 4 parts, it's this distance from here to here, because that's 4 parts of a line. Okay? And now I'm actually just going to take that distance on my compass, but I'm going to come to the opposite side of the line and swing an arc. And what you'll find is where the 2 arcs cross each other, that gives us our triangle. And if I connect that up, just heavy that in now. Okay, and just explaining on that, what we have now found was a line here at the base, which was 130 millimeters long. That was 6 parts, 6 portions. We have now found a distance for a line that was 3 portions, and we have also found a distance for a line that was 4 portions. 3 is to 6 is to 4. Now they gave us the distance of the longest side and they told us it was the base. So with the longest side, okay, obviously we looked up here what was the biggest ratio, and the biggest ratio was 6. So what we did was, with that 130, we did out 6 equals portions of 10. Okay, and with those equal portions of 10, we know then that if I found 3 of those portions, so I did that, well, going parallel to this line here, and I went out to the 3rd one, where that hit the line here at this point, having gone parallel, there and there, okay, having gone parallel, where the 3rd one went up, that distance there was 3 portions of a line that I needed for one of my sides. So took that distance on my compass and we swung up the arc. Then for the 4th portion, okay, so from here, 1, 2, 3, 4, for the 4th one, where it actually hits here, the distance from here to here was 4 parts of a line that I needed for the other side. Okay, and then taking that distance, we went to the opposite side of our baseline and swung an arc, and where the 2 arcs crossed each other, gave us the top of our triangle. Okay, that one there, a little bit trickier. Okay, given the clue, the longest side is equal to was the baseline. Okay, a little bit trickier, but as long as you understand the method, that should see you through on those questions, guys. Hope you found that helpful, guys. That's the questions complete there.